Today we'll discuss ISI's B-Stat B-Math 2020 UGA paper, and the first question is, for the function on the real line R given by fx equals mod x plus 1 plus e to the power x, which of the following is true? Now we know that mod x is continuous in R, mod x plus 1 is also continuous in R, an exponential function, it is also continuous. So this function is continuous in x belongs to R. Now what about differentiability? Now mod x is not differentiable at x equals 0. Mod x plus 1, it is not differentiable at x equals minus 1, and e to the power x, it is differentiable in x belongs to R. Now at x equal to 0, these two, they are differentiable, but this function is not differentiable, and x equal to minus 1, this x plus 1 is not differentiable. So this entire function fx, it is not differentiable at x equals to 0 and x equals minus 1. So the answer to this question is, it is differentiable everywhere except at x equals 0 and x equals minus 1, and that's your option number B. Now question number 2 is, if f and g are real valued differentiable functions such that f of gx equals x and f dash x equals 1 plus fx whole square, then we need to find the value of g dash x. Now we are given this differential equation, which is f dash x is equal to 1 plus fx square. So we can write this as dy by dx, and it is equal to 1 plus y square. So we can write dy upon 1 plus y square equals dx. If we'll integrate, we'll get tan inverse y equals x plus c. So from here we can say your function fx is tan x plus c. Now in the question it says f of gx is equal to x. That means gx is inverse function of fx. Now for inverse function, we simply replace x with y. So we'll get y as tan inverse x plus c, or we can write gx as tan inverse x plus c. Now we'll find g dash x, it'll be 1 upon 1 plus x square, and that's your option number A. Now another way of doing the same problem can be, we can write this as f of gx equals x, then f and g, they are inverse of each other. We can also write g of fx is equal to x. Now if we'll differentiate, we can write g dash fx into f dash x is equal to 1, then g dash fx, it will be 1 upon f dash x. Now f dash x is 1 plus fx whole square. Now we'll replace fx with x, we'll write g dash x as 1 upon 1 plus x square, and that again is option number A. Now question number 3 is, we'll need to find number of subsets of this set having odd number of elements. So these subsets can have either 1 or 3 or 5 or 9 elements. So that means number of subsets is given by 10C1 plus 10C3 up to 10C9. Now we know that NC0 plus NC2 plus NC4 is equal to NC1 plus NC3, and it is equal to 2 to the power n minus 1. So this value will be equal to 2 to the power of 10 minus 1, which is 2 to the power 9, and that is 512. So answer to this question is option number B. Now question number 4 is, we are given 64 players in a chess tournament, and they needs to be divided into 32 groups of 2 players each. So it will be 2, 2 and 2, and in all we need 32 groups. Now all these groups, they are unnamed distribution. So when it is unnamed distribution, we can divide them as factorial 64 upon factorial 2 factorial 2 factorial 2 32 times, and since it is unnamed group, we need to divide it by factorial 32, and that's your option number A. Now question number 5 is, we need to find number of real solution of this equation, which is e to the power x equals sin x. Now we'll draw the graph of sin x. That's the graph of sin x, and if we'll draw the graph of e to the power x, we know that is an increasing function. Now when x is less than 0, these two graphs, they'll intersect at infinite number of points. So the number of real solution of this equation is infinite, and that's your option number D. Now question number 6 is limit of sum. Now we know that this is summation k varies from 1 to n, 1 by n e to the power minus k by n. So we'll change it in integral form. So we'll replace k by n with x. So it'll be e to the power minus x. We'll replace 1 by n with dx. And then lower limit, when k is 1, it is 1 upon n. It'll be simply 0 and n upon n is 1. So the value of this integral is minus e to the power x upon minus 1 from 0 to 1. So it'll be minus and then e to the power minus 1, minus 1. So answer to this question will be 1 minus e to the power minus 1, and that's your option number C. Now question number 7 is, let f and g be differentiable functions on the real line with f0 greater than g0. Assume the set M, which is ft into gt, and let it be a non-empty set such that f dash t is always greater than equal to g dash t for all t belongs to M. Then which of the following is necessarily true? Now this set M, it contains all the point of intersections of fx and gx. Now what I'll do is, I'll consider a function and say this part it is constant, and then we have a differentiable function. Now say this function is fx, and let us consider another function which is say gx, which is also differentiable. Now for any point t in this interval which belongs to this set M, f dash t is equal to g dash t. So that means option number B, it may not always be necessarily true. It is true here when slope of fx is greater than slope of gx. If t belongs to M, then t is less than 0. That may not be necessarily true. So we may have solution on the positive side also. Now the third one is, for any t which doesn't belong to M, ft is greater than gt. Now this is true when t is greater than 0, because it is given that f of 0 is greater than g of 0, but it may not be necessarily true when t is less than 0. So that means option number A or C, they may not be necessarily true in all the cases. So answer to this question is D, none of the above. Now question number 8 is, consider the sequence 1, 2, 2, 3, 3, 3, 4, 4, 4, and it continues. We need to find what is 2020th term in the sequence. So what we'll do is, we'll say let 2020th term is k. So we'll have k, k and k, and then before that we'll have k minus 1. Now if we'll count all the terms starting from 1 to k minus 1, we know that there is only one term containing 1. There are 2 terms containing 2, 3 terms containing 3. Then up to k minus 1, there will be total k minus 1 terms. So total number of terms up to k minus 1, it will be 1 plus 2 plus 3 plus k minus 1. And this value, it should be less than 2020. Now since 2020th term, it lies in the sequence k. So it should be less than this value 1 plus 2 plus 3 up to k. So from here we can say k minus 1 by 2 is less than 2020 is less than k plus 1 by 2. So from the first one we'll get the result k square minus k minus 4040 should be less than 0, and k square plus k minus 4040 should be greater than or equal to 0. Now we'll solve these two conditions. We'll get the result that the value of k should be greater than or equal to 1 minus under root of 16161 upon 2, and it should be less than 1 plus under root of 16161 upon 2. Now this value is 63.66 something, and the other value is 64.06 something. So the only integral value of k possible in this case is 64. So the value of k is 64, and that's your option number C. Now question number 9 is, let A be the set x1, x2 up to x50, and B is y1, y2 up to y20. Now what are the total number of functions from A to B such that f is onto and fx1 is less than equal to fx2 and it is less than equal to fx50. So that means f must be an onto function and also f must be non-decreasing. Now we have 50 elements in this set A. There are x1, x2 and x50, and then there are 20 elements in set B, which are y1, y2 and y20. Now if we consider this y1 in B, then it will have a pre-image in A. Now let n1 represents number of elements in set A whose image is y1. So for y1 there will be n1 elements, then for y2 there will be n2 elements, for y3 there will be n3 elements, n4, and it'll go all the way up to n20, and this way all these 50 elements, they should be mapped. And since it is an onto function, so each of this ni should be greater than or equal to 1. So that means all we need to do is we need to find number of positive integral solutions to this equation. So we know that number of positive integral solution to the equation is given by n minus 1, which is 50 minus 1 c, 20 minus 1, and there'll be simply 49 c19, and that's your option number A. Now question number 10 is the number of complex roots of this polynomial z to the power 5 minus z to the power 4 minus 1 equals to 0 is. Now we can actually factorize this equation as z square minus z plus 1 and z cube minus z minus 1 equals 0. So we can write this as z square minus z plus 1 equals 0, or z cube minus z minus 1 equals 0. Now here z is 1 plus minus root 3 iota upon 2, so it will be minus omega n minus omega square. Now we look at mod z. In this case, mod of z will be simply 1. So here mod z is 1 for both minus omega n minus omega square. Now what about z cube minus z equals 1? So we need to find how many roots will have modulus 1. So let the root be r into e to the power iota theta, and r is 1, so we'll write this as e to the power iota theta. So it will be e to the power iota 3 theta minus e to the power iota theta, and it is equal to 1. Now from here we can write cos 3 theta minus cos theta equals 1, sin 3 theta minus sin theta equals 0. Now sin c minus sin d is 2 sin c minus d upon 2, so it will be 2 sin and then it will be theta and cos c plus d upon 2, so it will be cos 2 theta equals 0. So either theta is n pi or theta is 2n plus 1 into pi by 4. Now we'll solve this. We'll get minus 2 sin c plus d by 2, so it will be sin 2 theta and then sin d minus c by 2, and it should be 1. So from here we can write sin 2 theta into sin theta, it must be equal to minus 1 by 2. Now we'll take theta as n pi, it will be sin n pi, and sin n pi is 0. So it cannot be equal to minus 1 by 2. So there will be no simultaneous solution. Now what about theta equals 2n plus 1 pi by 4? If we look at 2 theta, it will be 2n plus 1 into pi by 2. So sin 2 theta will be minus 1 to the power n sin theta equals minus 1 by 2. Now sin theta, it is minus 1 by 2 at multiples of pi by 6 and not multiples of pi by 4. So we won't get any solution from this case. So there are only two roots for this equation for which modulus is 1. So answer to this question is 2, and that's your option number C. Now question number 11, it is pretty simple question. It says number of real roots of this polynomial are. Now for this one, x to the power 2020 plus 2020 x square plus 2020. Now this is positive, and this is positive. So it cannot be 0. Now this is a cubic equation. Now this cubic equation will have only one real root, and x square minus 2020, it will have two real roots. So the total number of real roots of this polynomial is 3, and that's your option number B. Now question number 12 is, which of the following is the sum of an infinite geometric sequence whose terms come from the set? Now suppose the first term is 1 upon 2 to the power a, and its common ratio will again be of the form 1 upon 2 to the power r. So we'll find sum of this infinite geometric progression will be a, which is 1 upon 2 to the power a upon 1 minus r, which is 1 minus 1 upon 2 to the power r. So we can write this as 2 to the power r minus a upon 2 to the power r minus 1. Now, every denominator here is an odd number and every numerator is 1. So it simply means this r, it must be equal to a, and this denominator, it should be of the form 2 to the power r minus 1. So the only number which is of the form 2 to the power r minus 1 is 7, because it is 2 cube minus 1, and that's your option number B. Now question number 13 is, the integral part of this summation is, now we can write 2 under root n, it is less than under root n plus 1, and L be greater than under root n plus under root n minus 1. Now we'll take reciprocal, then we can write 1 upon 2 root n, it is greater than 1 upon under root n plus 1 plus under root n, will be less than 1 upon under root n plus under root n minus 1. Now we'll multiply with its conjugate. We can write under root n plus 1 minus under root n is less than 1 upon 2 root n, and it is less than under root of n minus under root of n minus 1. Now we'll put n as 2, we can write root 3 minus root 2 will be less than 1 upon 2 root 2, and here will be root 2 minus 1. Now we'll put n as 3, we'll get root 4 minus root 3, and it is less than 1 upon 2 root 3 is less than root 3 minus root 2, and if we continue this series up to 9999, then we can write under root of 10,000 minus under root of 9999, it is less than under root of 9999 minus under root of 9998. Now if we'll add them all, then in that case this root 3 root 4, it will cancel. On the left hand side we'll get under root of 10000 minus root 2 is less than 1 by 2 this summation 1 upon root n, when n varies from 2 to 999, and it is less than, now on the right hand side everything will cancel and it will be under root of 9999 minus 1. Now we'll multiply it with 2. So we'll get 2, and then this square root will be simply 100 minus root 2 is less than this summation, it will be 2 times under root of 9999 minus 1. Now 200 minus 2 root 2 is 197.17 something, and then this summation 1 upon under root n, and it will be less than, and this is 197.99. So this value, it lies between 197.17 to 197.99. So greatest integral function of this summation 1 by square root of n, it will be 197, and that's your option number B. Now question number 14 is, let a and b number of subsets of 1 to up to n that does not contain any two consecutive integers, then a n is which of the following? So when we say it is a n, it will have all the numbers from 1, 2, 3 up to n minus 1 and n. We'll consider two cases. Case 1, when n belongs to a n, and second case when n doesn't belong to a n. Now when n belongs to a n, then a n cannot have n minus 1. So that means we'll need to select subsets from these n minus 2 numbers. So then in that case, number of subsets will be a n minus 2. Now if we do not select n, then we have to select number of subsets from these remaining n minus 1 numbers, and it can be done in a n minus 1 ways. Now these two cases, they are exhaustive and mutually exclusive. So a n should be a n minus 2 plus a n minus 1. Either this n will be included or it won't be included, and that's your option number A. If you want, you can verify it also. Suppose we have only one element. In that case, number of subsets will be 2, including 5. If we have two elements, 1 and 2, then number of subsets will be 3. If we have 1, 2, and 3, then 1 is 5. Then plus 3, 1, 2, or 3, and then plus 1, which is 1 or 3. So 2 plus 3, it is equal to 5, and that's your option number A. Now question number 15 is, if there are 128 numbers which are arranged in a circular pattern in clockwise order, and we start deleting numbers from the set in the clockwise fashion as follows. First delete the number 2, then skip the next available number, and then delete 4. Continue in this manner till only one number remains. What is the last number left? Now here 128, it is of the form 2 to the power n. When the numbers of the form 2 to the power n, then it is very simple to verify that the last number will be 1, and answer to this question should be A. Now suppose we have two numbers 1 and 2. Now here 2 gets deleted and we are left with 1. When we have 2 square, that is 4 numbers. Suppose 1, 2, 3 and 4. Now here first 2 and 4, they'll get deleted, and then 3 will get deleted. We're left with 1. Suppose we have 8 numbers 1, 2, 3, 4, 5, 6, 7 and 8. Now in the first attempt 2, then 4, then 6, and then 8, and then 3, and then 7, and then 5. So again we are left with 1. So when this n is of the form 2 to the power n, then 1 will always be the last number standing. And actually there is a general formula for this. The number of number that we'll get in the end, it will be 2n minus r plus 1, where n is the total number of numbers given, which in this case is 128, where r is the power of 2, which is closest to this number 128. Now we know that 2 to the power 7 is 128. So for this question, r itself is 128. So this is given by 2, and then 128 minus 128 plus 1. So it'll always be 1. And that's your option number A. Now question number 16 is, let Z and W be complex numbers lying on the circle of radius 2 and 3 respectively with center 0, 0. If the angle between the corresponding vertices is 60 degrees, then we'll need to find the value of mod Z plus W upon Z minus W. Now we know that Z, it lies on a circle of radius 2, and W, it lies on a circle of radius 3. Now angle between them, it is 60 degrees. Now if we write rotation of vectors, then we can say W upon Z is equal to mod of W upon mod of Z into e to the power iota, and then angle between them, and angle between them is pi by 3. So we'll write W upon Z, and this is mod of W. W lies on a circle of radius 3. So it'll be 3 by 2, and then e to the power iota pi by 3. E to the power iota pi by 3, it is nothing but it is cos pi by 3, which is 1 by 2, plus iota sine pi by 3, there'll be root 3 by 2. So we'll get W upon Z as 3 plus 3 root 3 iota upon 4. Now we'll use componendo dividendo, we'll get W plus Z upon W minus Z as 7 plus 3 root 3 iota upon minus 1 plus 3 root 3 iota. Now we'll take modulus sign. Then this modulus is 49 plus 27, and here will be 1 plus 27. So mod of W plus Z upon mod of W minus Z, it will be root 76 upon under root 28. So it'll be root 7, and here will be 1 and 9. So it should be under root 19 by under root 7, and that's your option number A. Now question number 17 is, two vertices of a square lie on a circle of radius r, and the other two vertices lie on a tangent to this circle. Then the length of the side of this square is. So we'll consider this circle. Without loss of generality, let us assume this tangent is this line, which is y equals r. Now we'll draw a square here. Now any point on the circle, we can write this as r cos theta and minus r sin theta, and let this point be minus r cos theta and minus r sin theta. Now this length, it will be 2r and mod cos theta, and this length, it will be r plus r mod sin theta. Now since it is a square, we'll get 2r mod cos theta, and it must be equal to r 1 plus mod sin theta. Now this r and r, it will cancel. We'll get 4 cos square theta and 1 plus sin square theta plus 2 mod sin theta. So we can write this as 5 sin square theta plus 2 mod sin theta and minus 3 equals 0. So we can factorize this as 5 mod sin theta minus 3 and then mod sin theta plus 1 equals 0. So from here we'll get this value, which is value of mod sin theta is 3 by 5. Now if the value of mod sin theta is 3 by 5, then we can write this length L as r and 1 plus mod sin theta, which is 3 by 5. So it will be simply 8r by 5, and that's your option number D. Now question number 18 is, we need to find number of real solution of this equation, which is mod of 2x minus greatest interior function of x, it is equal to 4. So we can write this as 2x minus greatest interior function of x, and it is equal to plus or minus 4. Now we'll take this first case. When it is plus 4, we'll get 2x minus greatest interior function of x, and it is equal to plus 4. We can write x as greatest interior function of x plus fractional part of x. So it will be 2 times fractional part of x minus greatest interior function of x, it is equal to 4. So from here we'll get fractional part of x as 4 minus greatest interior function of x divided by 2. Now we know that fractional part function, it always lie between 0 and 1. So we'll write 0, and this is 4 minus greatest interior function of x upon 2, and it lies between 0 and 1. So it will be 0, and then 4 minus greatest interior function of x is less than 2. We'll get minus 4, and then greatest interior function of x minus 2. So greatest interior function of x should be greater than 2 but less than equal to 4. So greatest interior function, it can only take integral values. So the only integral value possible in this case is either this value is 3 or greatest interior function of x is 4. Now we'll take greatest interior function of x as 3, then we'll get fraction part of x as 1 by 2. And in this case, value of x is 3 plus 1 by 2. That should be 7 by 2. And if greater function of x is 4, fraction part of x is 0. Here, the value of x is simply 4. Now we'll consider the second case. Now here again, we can write 2 times greatest interior function of x plus 2 times fraction part of x minus greatest interior function of x is equal to minus 4. We'll get 2 times fraction part of x as minus greatest interior function of x plus 4. Now again, it'll lie between 0 and 1, so it'll be 0 and then minus greatest interior function of x plus 4 divided by 2, and it should be less than 1. So we can write minus 2 is less than greatest interior function of x plus 4 is less than equal to 0. So here we'll get minus 6 is less than greatest interior function of x is less than minus 4. So here the two values of greatest interior function x possible are minus 4 and minus 5. So we'll get 2 solutions here and 2 solutions here. So total number of solutions to this equation is 4, and that's your option number A. Now question number 19 is, if sine of tan inverse x is equal to quad of sine inverse root 13 by 17, then x is. So we'll take this as theta, then this sine theta will be root 13 root 17. Now 17 minus 13 is 4. So this value will be 2. Now here cot alpha is 2 upon root 13. So we can write sine of tan inverse of x as 2 upon under root 13. Now we'll take tan inverse x as alpha. Then tan alpha is x upon 1. So it will be 1 plus x square. So sine alpha is x upon under root of 1 plus x square, and it is equal to 2 upon under root 13. Now we'll square it, we'll get 13x square, and it will be equal to 4 plus 4x square. So 9x square is 4. So value of x is plus or minus 2 by 3. Now here value of x is 2 by 3 since right hand side is positive. So that's your option number B. Now question number 20 is, if the word permute is permuted in all possible ways and written in alphabetical order, then 720th word is. So first thing that we'll need to do is we'll need to write these letters in alphabetical order. So we'll get E, then M, P, R, T, and U. So we have altogether 7 letters. Now total number of words that starts with E is given by, now we need to arrange these 6 remaining letters. It can be done in factorial 6 ways, and that is 720. So that means this 720th word is actually last word starting with E. Now how do we find last word starting with E? So we'll get this E, and then we have to write all these letters starting from U all the way up to E. So it'll be E, U, T, R, P, M, and E. And that's your 720th word. So it should be E, U, T, R, P, M, E, and that's your option number B. Now question number 21 is, the points 4, 7, minus 1, 1, 2, minus 1, minus 1, minus 2, minus 1, and 2, 3, minus 1 in R3 are vertices of what? Now the best thing in this question is all these Z coordinates, they are 1. So all of them, they lie on this plane Z equals minus 1. So we'll draw this plane and then we'll write these points. 1, 2, minus 1, and then 4, 7, minus 1, minus 1, minus 2, minus 1, and then 2, 3, and minus 1. Now, if we'll find midpoint of these two numbers, suppose this is A, B, C, and D. So what's midpoint of AC? Midpoint of AC will be 3 by 2, 5 by 2, and minus 1. In the same way, we can find midpoint of BD. Midpoint of BD will be 3 by 2, 5 by 2, and minus 1. Since the midpoint of AC and BD, they are same. So that means this quadrilateral is a parallelogram. Now we need to find whether it forms a rectangle. Now we'll find direction ratios of AB. So direction ratios of AB are 3, 5, and 0. And direction ratios of AD, they are minus 2, minus 4, and 0. Now if we'll take A1, A2 plus B1, B2 plus C1, C2, it is unequal to 0. So that means it'll form a parallelogram which is not a rectangle, and that's your option number C. Now question number 22 is, let fx and gx be functions on real line R such that both f plus gx and fx into gx are differentiable. Then which of the following is false? Now the first one is fx square plus gx square is necessarily differentiable. Now if we consider two functions, say hx and kx, then we can say that hx square minus 2kx will be a differentiable function. Now hx is fx plus gx whole square and kx is fx into gx. So from here we can say fx square plus gx square, it will be a differentiable function. So that means f square x plus g square x is differentiable. Now B is f is differentiable if and only if g is differentiable. So we know that sum of a differentiable function and a non-differentiable function is always non-differentiable. If one of the function is differentiable, then the other function must also be differentiable. So that means option B is also correct. Now the third one is fx and gx are necessarily continuous. So what we'll do is we'll take a counter example. Suppose we define fx as 0 when x is less than 0 and 1 when x is greater than or equal to 1, and we take gx as 1 when x is less than 0 and 0 when x is greater than or equal to 0. Now we'll find f plus g. When x is less than 0, it is 1, and when x is greater than or equal to 0, it is also 1. So f plus g is a constant function which is both continuous and differentiable. And if we multiply f into g, now in this case, when x is less than 0, it is 0. And when x is greater than or equal to 0, this is 0. which again is a continuous and differentiable function. So that means f and g, they need not be necessarily continuous. So that means the statement which is false is option number C. Now question number 23 is, let S be a set of, now question number 23 is, let S be the set consisting of all those real numbers which can be written as P minus 2A, where P and A are perimeter and area of right angle triangle having base length 1. So we have this right angle triangle and then base length is 1, area is half, base into height, base is 1, so height is 2A, so this is 2A, and if perimeter is P, then this third side will be P minus 2A minus 1. We write P minus 2A as some number n, so it will be simply n minus 1. Now if we use Pythagoras theorem, we can write 1 plus 4a square and it will be equal to n minus 1 square. So we write 4a square as n minus 1 square minus 1. So it will be simply n minus 2. Now we know that 4a square will always be greater than 0 because side it cannot be negative or 0. From here we'll get this condition that 0 and 2 will be plus, minus and plus. So value of n should be either greater than 2 or less than 0. And also this side n minus 1 should be greater than 0. That is value of n should be greater than 1. So the range of n is from 2 to infinite, and that's your option number A. Now question number 24 is, let S be the set from 1 to n and let LA denote the largest number in A. We need to find Fn, which is sum of all the numbers LA. Now first we'll find how many subsets will have 1 as the largest number. There will be only one such subset. How many subsets will have 2 as largest number? So if we have 2, then we have two options for 1. Either it will be there in this subset or it won't be there. Then it will be 2 such numbers. Then for 3, we will have 3 as the largest number, and then for each of 1 and 2, we'll have 2 choices each. So it'll be 2 square. For 4, it'll be 2 cube, and then for n, it'll be 2 to the power of n minus 1. So we'll have one set whose largest element is 1. We'll have 2 sets whose largest element is 2. We'll have 2 square subsets whose largest element is 3, and we'll have 2 to the power n minus 1 subsets whose largest element is n. Now we'll find Fn. Fn will be 1 into 1 plus 2 into 2 plus 3 into 2 square up to n into 2 to the power of n minus 1. Now what we'll also do is we'll write this Fn, but we'll write it after displacing one term. So it is 1 into 1, 2 into 2, n minus 1 into 2 to the power of n minus 2, and plus n into 2 to the power of n minus 1. Now we'll also multiply it with 2. So we'll multiply it with 2, we'll get 2, and then here will be 2 square, 2 to the power of n minus 1, and here it will be 2 to the power n. Now we'll subtract second from first, we'll get minus Fn, and here if we'll subtract, we'll get 1 plus 2 square plus 2 to the power of n minus 1, and then minus n into 2 to the power of n. So it will be minus Fn. Now this is nothing but a GP, so it is A, and then r to the power n minus 1 upon r minus 1 minus n into 2 to the power n. We'll get Fn as n into 2 to the power n minus 2 to the power n plus 1. So it will be simply n minus 1 into 2 to the power n plus 1, and that's your option number D. Now question number 25 is, if A, B, C are distinct odd natural numbers, then number of rational roots of this polynomial ax square plus bx plus c is. Now for rational roots, its discriminant must be a perfect square. So we can write D, and we can write this as b square minus 4ac, and it should be equal to some perfect square, say n square. Now this b is odd and 4ac is even, so that means this n, it is an odd number. We can write 4ac as b plus n and b minus n. Now let us say b is some 2k plus 1 and n is some 2l plus 1. Then we can write 4ac, and then b plus n will be 2k plus 2l plus 2, and b minus n will be 2k minus 2l. Now here 4 will cancel, then we'll get ac as k plus L plus 1 and then k minus L. Now if we look at this product, k plus L minus 1 into k minus L, this product, it will be an even number. Because if k minus L is even, then this product will be even. But then A and C, since they are both odd natural numbers, so left hand side is odd and right hand side is even. So that means there cannot be any solution to this equation. If we'll consider this other case when k minus L is odd, then k plus L will also be odd. In that case, k plus L plus 1, they'll be even. So in either case, this right hand side will always be an even number and left hand side will be an odd number. So there cannot be any solution to this equation. So number of rational roots of this polynomial must be 0, and that's your option number A. Now question number 26 is, let A, B, C be finite subsets of planes such that A intersection B, B intersection C and C intersection A, they are all empty, and let S be A union B union C. Now assume that no 3 points of S are collinear, and also assume that each of A, B, C has at least 3 points, then which of the following statement is always true? A, there exists a triangle having a vertex from each of A, B, C that does not contain any point of S in its interior. Now we have 3 finite subsets, A, B and C, and each of these subsets will have at least 3 points. Now for option A, what we'll do is we'll consider a triangle with points in A, B and C, and we'll consider a triangle of least area. So in any case, it will always be possible to construct a triangle having the least possible area. Now, if there exists a point S interior of this triangle ABC, which belongs to the set S, then in that case, this triangle APB, it will have this area which is smaller than ABC, which is a contradiction because we have already assumed that area of this triangle ABC is the least. So that means it is always possible to have a triangle that does not contain any point of S in its interior. So answer to this question is option number A itself. Now question number 27, it's a standard Bayes theorem question. We are given that some person is allergic to certain thing and there is a test for that. So this test, it is known to give the following result. For people who really do have the allergy, the test says yes 90% of the time, and for people who do not have the allergy, test says yes 15% of the time. If 2% of the population have this allergy and the test says yes, what is the chances that this person does really have the allergy? Now this person can have the allergy or does not have the allergy. So what is the probability of having the allergy? Probability of having the allergy is simply 2 by 100 and not having allergy is 98 by 100. Now probability that the report confirms yes if the person has allergy is 90%. So it will be simply 90 by 100, and the probability the report confirms yes if the person doesn't have allergy is 15%. So there will be 15 by 100. Now we need to find the probability that this person does really have the allergy. We'll take this case when the person has the allergy in the numerator and then total case in the denominator. We'll have this result as 2 into 100 into 90 upon 100 divided by 2 into 100 into 90 upon 100 plus 98 upon 100 into 15 upon 100. So this 100 will get cancelled. Now we'll cancel this 15 also. So it'll be 6 and 6. So it'll be simply 12, and this is 12 plus 98. So it should be 12, and then 12 plus 98 is 110. It'll be simply 6 by 55, and that's your option number B. Now question number 28 is number of points of discontinuity of the function gx equals greatest linear function of x square minus 2 in the interval minus 3 to plus 3. We can write gx as greatest linear function of x square minus 2. Now this minus 2 is constant function which is continuous and differentiable. That means we just need to find continuity of greatest linear function of x square between minus 3 and plus 3. So between minus 3 and plus 3, if we'll draw this graph, so this is 0, this is minus 3 and this is plus 3, its value will be 9. So this value, it is 9, and since minus 3 and plus 3, they are not included, we don't have a problem with minus 3 and plus 3. Now we'll draw horizontal lines at 8, 7, 6, 5, 4, 3, 2 and 1. So we'll have 1, 2, 3, 4, 5, 6, 7, 8 point of intersections on the left and 8 point of intersections on the right. So there'll be total 16 points of discontinuity, and that's your option number D. We have already discussed transformations of greatest standard function in one of the previous videos. I'll provide the link to that video in the description below. Now question number 29 is, find the area of the region in the plane R square given by the points x, y satisfying mod y is less than equal to 1 and x square plus y square is less than equal to 2. So second one, it represents a circle of radius root 2 and then points lying inside this circle. And the first one is this region where the value of y is between -1 and +1. So we'll need to find this area. So first what we'll do is we'll find this point of intersection. So we'll put y is 1, we'll get x is 1. So this point is 1, 1 and this point here it will be -1, 1. Now this is the origin. This angle will be 45. This angle here will also be 45. So this angle is 90 degrees. So first we'll find area of this segment. So suppose this area is A1. So area of segment A1, it will be 1 by 2 r square. R square in this case is 2 and then theta minus sine theta. Sine 90 is 1. So here 2 and 2 will cancel. We'll get this as pi by 2 minus 1. Now what's the area that we'll need? So this area will be area of the circle and that is pi r square minus 2 times this area. So it will be 2 times and then pi by 2 minus 1. So it will be 2 pi minus pi plus 2. So it will be simply pi plus 2 and that's your option number C. Now question number 30 is, if n is a positive integer and t belongs to 0 to 1, then this summation r varies from 0 to n, r n cr t to the power r 1 minus t to the power n minus r equals what? So what we'll do is we'll write binomial expansion of x plus y to the power n, and we know that this is equal to ncr x to the power n minus r y to the power r. Now we'll partially differentiate it with respect to y. We'll write n x plus y to the power n minus 1 and then summation r into ncr x to the power n minus r into y to the power of r minus 1. Now we'll need to restore its power to r. So we'll multiply it with y. We'll get ny into x plus y to the power n minus 1 and it'll be equal to summation r ncr x to the power n minus r into y to the power r. Now in our question we'll need t to the power r and 1 minus t to the power n minus r. So what we'll do is we'll replace x with 1 minus t and y with t. So we'll get n into t and here it'll be 1 to the power n minus 1 and it'll be equal to the summation r ncr 1 minus t to the power n minus r into t to the power r, which is equal to n into t, and that's your option number A.